Good afternoon. My name is Junyi, and I'm from IVPP in China. I'm so glad to introduce our works about the human occupation on the Central Tibet during the past 45,000 years. And this picture shows the Tibetan Plateau. And the Central Tibetan Plateau have altitudes almost over 4,000 meters in average. This poses great challenges for people's survival and adaptation. And just because it means the cool temperatures and the scarce food supplies and also dangerous of hypoxia. But the timing and the mechanism of the initial prehistoric colonization and adaptation to the plateau by hunter-gatherers is an interesting topic and have been studied intensively in the past decades, but it remains ambiguous. For example, in genetic perspective, the genomic studies show that ancestors Tibetans have occurred and just 60 to 30,000 years ago, and the modern Tibetan gene pool mostly originated during the early Holocene. But when we look at the archaeological evidence, it looks much more complex. And the archaeologists suggest multiple phases, but a step-by-step model for the human occupation. And for example, during since the Middle Pliocene, there are some the Denisovans and occupied and the northeast of the Tibetan Plateau. But and after that, the hunter-gatherers began to disperse onto the Central Plateau, Central Tibetan Plateau, and only after 3.6 years, and the agricultural population and finally finished their permanent occupation on the Tibetan Plateau. But our works mainly focus on the Central Tibetan Plateau because we want to try to understand when and how did the Paleolithic populations occupy the Tibetan Plateau hinterland, and which population may have contributed to the gene pool of the modern Tibetans. So in the past 10 years, our group have made a lot of surveys and also made some excavations there, and we found at least 30 Paleolithic sites just around the Silin tour, and the Nwya site is the first Paleolithic site has been ever discovered, and with the good artifact bearing stratigraphy, and this is very interesting that on this side we found two lithic assemblages. The one is the IOP blade assemblages, another one is microlithic assemblages. But the dating is a problem for this side because the organics for the radiocarbon dating is probably reserved in this side. So we have to do some intensive sieving to try to find some methods for radiocarbon dating, and at the same time I also do some high resolution OS dating and this side to this side. And for the IOP plate assemblages is only uncovered from the higher lake terrace of the Nwya located one here, and we made the excavation, and the stratigraphy is good, and the sediment sequence can be divided into 3 layers, but we think our studies show that there are only the layer 3, the lowest layer 3 is the main undisturbed culture layers, and our preliminary Earth dating dated these layers to 40 to 3,000 years ago. So this result, preliminary studies was published in 2018. After that, when we examined the stratigraphy, we found another layer 4 just on this corner, and fortunately we also found some artifacts just around the bottom of this layer 3. This is the main culture layers. So we did some more Earth datings along this sequence. So finally, we made a BS analysis based on all the Earth ages, and we got the final ages for the layer 3s from 45,000 years to 27,000 years. But for the microplate assemblies and the Nwya Ge side, they are unrecovered from the lower lake terrace, and we made an excavation and this is three pits, and we found that most of the artifacts were discovered in the dune sand, and occasionally they can find at the top of the fluvial constraint layers just below the dune sand. So we made made some Earth datings for this located, and fortunately we also found some freshwater shells from the fluvial constraint layers, and dated using the carbon dating, radiocarbon dating, and finally when we combine all the ages and did the Bayesian analysis, and we got a very small time age ranges for this assemblies is only from between just 11 to 10,000 years ago. So it represents the earliest microlithic sites on the central Tibetan Plateau. With these ages, we can reconstruct the landscape changes on this side, and we can see that just before the deposition of layer 3, there could be to almost 20,000 years sedimentary hiatus just between the layer 4 and layer 3. And from the 45 to 27,000 years ago, I think there should be could be a minor hydrological environment changes, so that allows the sediments deposition on this side. And it's very interesting that during the MS2, there almost no sediment, no deposition on this side. From 15 to 11,000 years, there's a high standard of lake levels, and it affects the sites depositions. But after that, I think this site becomes more stable hydrological environment, so that provides a suitable habitat for macrolith population again. So we can say that our sites record 2 waves of human occupation, and the first one is blade populations. We know that from the 50 to 70 years ago, and the IUP population have dispersed across the Central Asia and to the Mongolia steppe, and when we compared our results with the ages of these IUP populations, we can find that this wave of modern human have conquered the Eurasia and also the Tibetan Plateau. And the second wave of the human occupation on our side was the microplate population. It's very interesting that during the past 10 years, we found at least more than 100 microlith sites, and these ages range from the 10,000 years to 3,000 years. It means that this population can survive successfully on the Tibetan Plateau. And when the compared studies was conducted, and it shows that there are a clear technology connection between the microlithic techniques between the Central Tibetan Plateau and that from North China. So it means that could be before 10,000 years ago, and the microplate people can expand it from the North China to the Central Tibetan Plateau. We have noticed that the genetic evidence have shown that the modern Tibetan gene pool have originated almost 10,000 years ago. So it means that this microlith population may have contributed a lot to the formation of the modern Tibetan gene pool. It's very interesting that very interesting question is since there are two populations have ever occupied on the Central Tibetan Plateau, are there continuous occupation or not? And I think to understand this question, the most important point is we know that it suggests that the cold and dry last gradual maximum climate may have interrupted the occupation on the Central Tibetan Plateau. So when we look at this question, we need to try find some evidence about this. And so when we look at the genetic evidence, and some studies show that there are coexistence of Paleolithic and microlithic ancestries in the Tibetan Plateau gene pool, and which suggests that there could be genetic continuity between the prehistoric highland forages and the present Tibetan plateaus. But there only be a bottleneck during the RGM period. So another question is the environment changes or the environmental conditions is possible to support the survival of this the continuity, the possible continuous occupation on the Central Tibetan Plateau, and our simulated available photo resources during the RGM clearly shows that there are high resource density in large valleys just in the southern and the eastern of the Tibetan Plateau, and the population density data also show that during the Neolithic period, and there are also habitable environment in this large valleys during the Neolithic period. So it means that large valleys may have been relatively stable habitats for for the human foragers, even during the cold and inhospitable RGM period. But we need more evidence in the future to test this hypothesis. So come to our conclusion. First one, and firstly, the plate and the microplate assemblies from the Nwya Devu side were dated to 45 and 10,000 years ago, suggesting they are the earliest known Paleolithic and Microlithic sites on the interior of the Tibetan Plateau, indicated that there could be multiple occupation episodes of modern humans during the past 45,000 years ago. And secondly, our analysis pushed the modern humans dispersal onto the Tibetan Plateau back to 45,000 years ago. Thus is contemporaneous with the spread of modern humans in Eurasia, and suggests a rapid and extensive wave of modern humans under relatively stable and stable climate conditions during the late MS3. And the concordance between the genetic and archaeological records from the Tibetan Plateau suggests a possible genetic association between the early modern human and the modern Tibetans. The Tibetan Plateau highland may have been a relatively stable habitat for human foragers, thus can encourage the subsequent multiple modern humans dispersals from the lower land. That's my talk. Thank you.